All right, today we're going to dive into something that's at the very heart of all programming. How in the world does code actually make decisions? We're going to pull back the curtain and see how really simple instructions can make our devices seem so smart.
I mean, really think about it for a second. How does your phone or your laptop or any website know that you've typed in the wrong password? It's not magic, I promise. It's a decision. And by the time we're done here, you're going to understand exactly how that decision gets made.
You see, at the core of every app, every game, every website, there are just countless decision points. The best way to think about them is like a crossroads, where the code has to pause and ask, okay, which way do I go now?
We do this kind of thing all day long without even thinking about it, right? Our brains are constantly checking things. If it's raining outside, then you grab an umbrella. If it's not, in other words, else, you might grab your sunglasses. Well, that exact same logic, that's the bedrock of how computers think. Now, in the programming world, there's a name for this. It's called a conditional statement. That's the official term for that crossroads. It's just the point where the code asks a simple question, and the answer, which can only be true or false, decides everything that happens next.
So let's start with the most basic version of this, the classic fork in the road. This is the if-else choice. If something is true, do this one thing. If it's not, or else, do this other thing instead.
A flowchart, just like this one, is the perfect way to visualize it. It's literally a map for a decision. Our program gets some information, in this case a cost, and it follows the arrow until it hits that diamond shape. That diamond, that's our crossroads. And the question inside that diamond, that's what we call the condition. It's a test that can only have two possible answers, true or false, yes or no. There's no maybe. Here, the computer is just asking one simple thing. Is the number I have for cost less than 22? So drawing it out in a flowchart is one way to get your head around the logic. But another way is to write it out in what we call pseudocode, which is basically a simplified, human-friendly version of code. The key thing to realize here is that both of these are telling the exact same story, just using a different language. So the pseudocode just says it out loud. If the cost is less than 22, then tell the user you can afford it. Else, tell them you cannot afford it. See, it's a perfect one-to-one translation of that flowchart. It's simple, but the structure is unbelievably powerful.
But life isn't always a simple yes or no choice, is it? What happens when you need to check for a few different things before you can make a final call?
For that, we just add a couple more tools to our toolkit. We always start with an if, that's our number one most important check. But then we can add as many else-if blocks as we need to look for other specific things. And finally, at the very end, we have our catch-all, the else. This is what happens if nothing else we checked for was true.
Okay, let's go back to our password example. This piece of code here is designed to spot a couple of really common, really weak passwords. It's the perfect real-world example of using if, else if, and else all working together.
So let's do this. Let's put on our computer thinking hats for a minute and walk through exactly what this code does when it sees a few different passwords.
Okay, first try. The user types in password. I know, super creative, right? The program takes that word and gets ready to run down its checklist, starting right at the top.
So the very first thing it checks is if the password equals password. And ding, 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 it's true. So the code immediately runs the instruction tied to that condition. It tells the user that's not a good password, and then it just stops. Its job is done. It doesn't even look at the other checks.
But what happens when that first check fails? Let's say this time the user types in 1234. The code starts the whole process over again, right from the top. So it asks, is the password equal to password? Nope, that's false. So it just moves on to the next check in line. Okay, else if the password equals 1234. And this time it's true. So it fires off the warning message for that specific password, and just like before, it stops. Decision made.
So how does a good password ever get through this? Well, let's say we type in mycatrocks26. The code does its thing. Is it password? Nope. Is it 1234? False again. Since it went through all the specific if and else if checks and none of them were true, it has no choice but to fall back to that final else statement. That's our safety net, our none of the above option, that finally accepts the password.
Now that you see how this works, you're going to start noticing it absolutely everywhere. This simple building block is making countless little decisions for you all day, every day. Seriously, an ATM is just checking if you have enough funds. A thermostat asks if the room is too cold. Your alarm clock checks if it's a weekday before it goes off.
Every single one of these actions is just being driven by that same fundamental if, then, else logic we just walked through.
And really, that's the big secret here. When we see a computer or phone acting smart, what's really happening under the hood is just a massive, complex tree of these incredibly simple, lightning-fast, true or false decisions, all chained together to create some pretty sophisticated results. So next time you log into a website, check the weather, or start your car, just think about all those silent questions being asked and answered in the background. It makes you wonder, what's the most important decision a computer made for you today? Thanks for watching.